Hello and welcome. If you're settling in for the night or just taking a quiet moment to relax and unwind, I'm glad you've chosen to spend this time pondering some of the deepest mysteries of our universe. As you get comfortable, I invite you to share in the comments where in the world you're listening from and what time of day it is for you. It's always a joy to know that these words are reaching curious minds like yours all across the globe at all hours. If you find yourself enjoying this kind of calm, thoughtful exploration, I encourage you to subscribe. There's so much more to discover together, but for now, let's allow ourselves to drift to the very edge of the known cosmos and imagine what lies beyond. Out there in the vast expanse, beyond the reach of even our most powerful telescopes and brilliant minds, the universe continues, an endless frontier waiting to be explored, if only in our dreams and imaginations. It's a question that has captivated humans for as long as we've turned our eyes to the stars. What wonders and mysteries might we find out there in the uncharted reaches of space and time? Though the furthest depths of the cosmos are hidden from our view, that hasn't stopped the curious from peering into the void and imagining what might be. Ancient astronomers like Ptolemy and Aristotle gazed up at the night sky and saw it as a finite sphere, with the Earth at the very centre. But as technology and human knowledge advanced, so too did our understanding of the true scale and structure of the universe. It was Edwin Hubble, in the early 20th century, who first began to grasp just how expansive the cosmos truly is. As he studied distant galaxies, he noticed something peculiar. The light coming from them was shifted toward the red end of the spectrum. The more distant the galaxy, the more extreme this redshift appeared to be. Hubble realized that this could only mean one thing. Those galaxies were moving away from us, and the further away they were, the faster they were receding. This revelation shook the very foundations of cosmology. The universe, Hubble showed, was not a static and unchanging place, as many had long believed. Instead, it was something dynamic and ever-expanding, with galaxies being carried away from each other by the very stretching of space itself. It was as if they were raisins in a loaf of rising bread dough, being pushed apart as the dough expanded. Hubble's groundbreaking discovery painted a whole new picture of the cosmos, one that was full of motion and change on the grandest of scales. As he peered deeper into space with his telescopes, he could see that this expansion was happening in all directions, everywhere he looked. The universe wasn't just vast in size, it was also growing larger with each passing moment. This brought up a profound and somewhat melancholy realization that as the universe expands, galaxies are steadily carried away from us by the stretching of space. And at a certain distance, known as the cosmic horizon, this expansion is happening so quickly that it outpaces the speed of light itself. Once a galaxy crosses that horizon, the very space it occupies is stretching away faster than its light can travel back to us. It means that galaxy, and all the stars and worlds it contains, are lost to us forever, never to be seen again from our cosmic vantage point. Even now, as you listen to these words, innumerable galaxies are slipping across that horizon, drawn by the relentless expansion of the universe. With each passing second, more and more of the cosmos is receding from view, carried off into realms unknown. It's a poignant reminder of how much of the universe has already passed beyond our ability to explore, fading into the mists of cosmic history. But though these distant reaches may be forever hidden from us, that doesn't stop us from imagining what lies beyond the boundaries of the observable universe. After all, the cosmos had already been expanding for eons before we humans ever looked up and began to wonder about its true extent. To really understand what the universe is like beyond our field of view, we need to rewind the clock, to journey back in time to the very birth of the cosmos itself. According to our best theories and observations, the story of our universe began some 13.8 billion years ago, in an event we call the Big Bang. But despite its name, the Big Bang wasn't an explosion in the usual sense, with matter and energy being flung violently outward from a central point. Instead, it marked the beginning of space and time themselves, with all the matter and energy of the observable universe emerging from an infinitesimally small, incredibly dense, and unimaginably hot state. In those first few moments after the Big Bang, the universe was a seething cauldron of energy, so hot that the fundamental forces of nature were unified into a single, all-encompassing force. As the newborn cosmos expanded and cooled in the tiniest fractions of a second, it underwent a series of incredible transformations. Quarks combined to form protons and neutrons, the building blocks of atomic nuclei. After just a few minutes, these particles began to fuse together, forming the first light elements like hydrogen and helium, and bathing the universe in a scorching plasma. It would take another 380,000 years for the universe to cool enough for electrons to bind with atomic nuclei, forming stable neutral atoms. In that moment, the cosmos became transparent for the first time, allowing light to stream freely through space. That ancient light stretched and redshifted to microwave wavelengths by billions of years of cosmic expansion is still detectable today as the cosmic microwave background radiation, a distant echo and snapshot of the infant universe. One of the first to grasp the true implications of this primordial radiation was a Belgian physicist and priest named Georges Lemaitre. In the late 1920s, years before Hubble's revelation of the expanding universe, Lemaitre proposed that the cosmos had originated from what he called the primeval atom, a single point that had contained all the matter of the universe before expanding to its current size. It was a revolutionary idea, one that upended the conventional wisdom of an eternal and unchanging cosmos. Lemaitre's model of a universe born in a distant past, expanding and evolving over eons, laid the groundwork for what we now know as Big Bang cosmology. He recognized that by running the clock backwards, by reversing the expansion that Hubble had observed, one would ultimately come to a moment of origin, a cosmic birth from which the entire known universe had sprung. It's a staggering thought to contemplate, that everything we see from the ground beneath our feet to the stars shining down from above was once compressed into a speck smaller than a single atom. And yet, from that humble beginning, a cosmos of astonishing scale and complexity has emerged. A universe filled with 100 billion galaxies, each brimming with billions upon billions of stars, worlds, and perhaps even fellow wanderers peering up into the same shared sky. But even the observable portion of our universe, as incomprehensibly vast as it is only a small slice of a much larger cosmos. Most of the volume of space was likely pushed far beyond our view in the first instant after the Big Bang, driven by a process called cosmic inflation. This is the idea, first proposed by physicist Alan Guth in 1980, that the newborn universe underwent a brief but incredible period of exponential expansion, doubling in size every tiny fraction of a second. During this inflationary epoch, space itself expanded faster than the speed of light, a cosmic growth spurt that took a microscopic volume and enlarged it to astronomical proportions. This rapid ballooning stretched out the tiny quantum fluctuations present in the early universe, magnifying them to cosmological scales and sowing the seeds of cosmic structure. Without inflation, it's hard to explain the incredible smoothness and flatness of space we observe today, or the subtle variations in density that would eventually give rise to galaxies, stars, and planets. Inflation also provides a possible answer to the question of what lies beyond our cosmic horizon. If the theory is correct, the observable universe is just a small bubble in an enormously larger space, one that was inflated far beyond our view in that first fraction of a second. Most of the true volume of the universe, in this picture, is forever inaccessible to us, pushed away by the expansion of space itself. But the implications of inflation go even further. Some versions of the theory suggest that our universe is just one of countless bubble universes, each one sprouting from an eternally expanding multiverse. In this view, the process of inflation never truly ends. It continues forever in some regions of space, spinning off new bubble universes all the time. Each of these universes may have its own unique properties, its own set of physical laws and constants, born out of the quantum fluctuations that were stretched and frozen in by inflation. If this picture is correct, it means our universe is just one island in an unimaginably vast cosmic archipelago, a single bubble adrift in an eternally inflating sea. The true extent of reality would be far greater than what we see within our observable slice, a multiverse of astonishing scale and variety, one in which our entire cosmos is but a tiny fragment. It's a concept that pushes the boundaries of human imagination, to zoom out in our mind's eye and try to envision this grander cosmic context. An eternal expanse, forever giving birth to new and diverse universes, each one a self-contained experiment in the possibilities of physics and complexity. In this view, everything we know, all the stars and galaxies, all the beauty and structure within our observable bubble is just one tiny corner of an endlessly rich and varied multiverse. The idea of the multiverse remains speculative, a tantalizing possibility that follows from our theories but has yet to be confirmed observationally. But it's a reminder that even the most basic facts of our existence, the particles and forces that shape our world, the constants of nature that allow complexity to arise, may not be the only ways a universe can be, that perhaps we live in a cosmos that is not only stranger than we imagine, but stranger than we can imagine from our limited vantage point. As we ponder these questions of what lies beyond, both in space and in possibility, it's hard not to feel a sense of awe and humility, to recognise that for all our knowledge and achievement, we've still only glimpsed the tiniest slice of a much larger and perhaps endlessly varied reality. And yet, that glimpse is enough to fill us with wonder, to ignite the spark of curiosity that has carried us from the first campfires to the frontiers of cosmic understanding. But there is another dimension to consider, beyond the spatial scope of the universe, and that is time, the great unfurling of moments that carries us from past to future. Having explored the far reaches of space and the earliest eras of cosmic history, let us now turn our gaze in the other direction, to the unwritten chapters that await our universe in the eons to come. From our vantage point in the present, the future seems wide open, full of possibility and promise. But just as the expansion of the universe has carried galaxies beyond our view, so too will it continue to shape the cosmos on the grandest scales of space and time. As the eons unfold, gravity will continue to pull galaxies together into ever larger structures, great walls and filaments spanning billions of light years, surrounding vast cosmic voids. On the scale of individual galaxies, this process of structure formation will play out as a majestic dance of collision and merger. Over the next few billion years, our own Milky Way will be drawn into an intimate gravitational embrace with the neighbouring Andromeda galaxy. The two great spiral arms, each home to hundreds of billions of stars, will intertwine and distort as their mutual gravity tugs at gas, dust, and starlight. In a process taking hundreds of millions of years, the galaxies will pass through each other again and again, their stars sliding past one another without colliding, until the two distinct structures merge into a single, grand, elliptical galaxy. It's a future that's at once breathtaking and melancholy. The end of our cosmic island is a separate entity, but the birth of something even more vast and ancient, a realm of starlight that will endure for countless ages. But even as galaxies come together under the pull of their own gravity, the expansion of the universe continues unabated, driven by the mysterious repulsive force we call dark energy. In 100 billion years, give or take, this expansion will have carried all but the closest galaxies beyond our cosmic horizon, leaving our merged Milky Way Andromeda galaxy as an island universe in an increasingly empty sea of space. From that distant future vantage point, the cosmos will appear very different than it does today. The grand ballet of the galaxies, the great structures woven by gravity over billions of years, will have receded from view. An observer in that far future universe looking out into the void might see little more than our lonely merged galaxy, floating in a vast and seemingly unchanging expanse. And yet, even that island universe will not endure forever. On the scale of trillions of years, the last stars will flicker out one by one, their fuel exhausted, leaving behind only dim stellar embers and the slumbering remnants of once bright suns. Even the grand forges of creation, the great molecular clouds that gave birth to whole generations of stars, will be depleted and dispersed. In that far distant era, the universe will be a much darker and more diffuse place, with the galaxy's starlight all but extinguished. The great engines of energy and complexity that filled the cosmos with light and life for eons will have wound down, leaving only darkness in their wake. It's a prospect at once chilling and poetic, a universe fading into a long, cold night. But even that night will not be eternal. Over unimaginable gulfs of time spanning perhaps 10 to the power of 100 years or more, even the black holes that once anchored the hearts of galaxies will slowly evaporate, leaking their mass and energy back into the void through the drip, drip, drip of Hawking radiation. Matter itself will decay, with protons and neutrons dissolving into a thin gruel of lonely particles drifting through ever-expanding space. this is the fate that awaits our universe in the far distant future, according to our current understanding. A slow, inexorable slide into a state of maximum entropy, with all structure and complexity eroded by the ceaseless march of time. It's a cosmic story that ends not with a bang, but with a whimper, an inky void, growing ever colder and more diffuse as the eons unfold. This ultimate fate, sometimes called the heat death of the universe, has a certain poetic melancholy to it. To picture all the richness and grandeur of the cosmos, all the starlight and beauty and possibility slowly winding down into darkness and silence. There is a sombre inevitability to it, the knowledge that even a universe as vast and ancient as ours must someday fade away. And yet, even in that far future darkness, there is a strange and subtle beauty. The idea that the cosmos, having flowered into astonishing complexity, will settle into a peaceful quiescence, like a ripple fading on the surface of a still pond. That the story of the universe, grand and sprawling as it is, will someday reach a quiet denouement, with all its plot threads resolved into a tranquil equilibrium. From our vantage point, living on a pale blue dot orbiting a middle-aged star, that ending is almost unimaginably remote. The universe we inhabit is still vibrant and dynamic, filled with the light of countless suns and the vast churning structures of the cosmic web. We are fortunate to be here now, able to trace the grand story of the cosmos from its fiery birth to the majestic tapestry of galaxies we see today. And we are doubly fortunate as conscious beings to be able to contemplate that story, to follow the trail of evidence and inference that leads us back to the Big Bang and forward to the ultimate fate of the universe. We are, as Carl Sagan so beautifully put it, a way for the cosmos to know itself. The universe, after eons of unconscious evolution, has awoken to its own existence through us. That is a profound and humbling thought, that we, for all our flaws and limitations, carry the spark of cosmic self-awareness. That our drive to explore, to discover, to understand, is the universe looking back on itself with wonder. We are stardust pondering the stars, matter marvelling at the depths of space and time from which it emerged. And though much of that space and time may lie forever beyond our reach, hidden behind cosmic horizons or the veil of the far future, that doesn't diminish the grandeur of what we can know and imagine. The observable universe, the slice of space and time that we can explore, is a cosmos unto itself, filled with enough beauty and mystery to occupy our minds for countless generations. In the centuries since Hubble and Lemaitre peered into the depths and caught a glimpse of our universe's origin and expansion, we have traced the story of the cosmos in astonishing detail. From the fluctuations of the primordial plasma to the birth of the first stars and galaxies, from the forging of heavy elements in stellar furnaces to the slow dance of worlds around newly formed suns, the grand arc of cosmic evolution has unfolded before our eyes. We have learned to read the subtle echoes of the Big Bang in the cosmic microwave background, seeing in its gentle ripples the seeds of all the structure we see today. We have probed the hearts of stars and the edges of black holes, witnessed the collision of neutron stars and the birth of spacetime itself. And we have looked back to the cosmic dawn, seeing the first luminous objects flicker on in the aftermath of the Big Bang. Each of these discoveries is a testament to the power of the curious mind, the ability of mere matter to rise up and comprehend the cosmos from which it sprang, and each one spurs us onward, inviting us to probe further and deeper. As we ponder the incredible timeline of our universe, from its fiery birth in the Big Bang to its eventual descent into darkness eons from now, it's hard not to feel a profound sense of awe. The sheer scale of the cosmos in both space and time is almost incomprehensible to our human minds. And yet, throughout history, there have been visionaries who dared to study this immense universe we find ourselves in, to ask the deep questions and follow the evidence wherever it leads. One such visionary was the Belgian Catholic priest and astronomer Georges Lemaitre. In the 1920s, at a time when most scientists believed the universe was static and eternal, Lemaitre proposed a radical idea, that the universe had a beginning. Digging into Albert Einstein's groundbreaking theory of general relativity, Lemaitre realized something astonishing, that space itself could expand. If space could expand, Lemaitre reasoned, then it must have been smaller in the past. Winding the clock back, he imagined all the matter and energy of the universe compressed into an incredibly dense point, a primeval atom, as he called it. This atom was highly unstable, and around 13.8 billion years ago, it exploded in a tremendous burst of expansion that gave birth to space and time themselves. Though he didn't know it at the time, Lemaitre had just envisioned the Big Bang. It's amazing to think about, that everything we see around us, from the ground beneath our feet to the most distant galaxies, all came from an infinitesimal point in the far reaches of the past. In those first few moments after the Big Bang, the universe was inconceivably hot and dense. As it expanded and cooled, it underwent incredible transformations. In the first billionth of a second, the fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces froze out of the searing maelstrom. Subatomic particles called quarks combined to form protons and neutrons. After a few minutes, these particles fused to create the first light elements, mostly hydrogen and helium, with a sprinkle of lithium. For hundreds of thousands of years, the infant universe was a sea of scorching plasma, with light and matter coupled together in an opaque fog. But as space continued to expand and cool, something remarkable happened. Around 380,000 years after the Big Bang, the universe had diluted and cooled enough for electrons to join, with atomic nuclei, forming the first neutral atoms. Light was finally able to decouple from matter and stream freely through space. This ancient light, called the cosmic microwave background, still fills the universe today. It's the oldest light we can see, a snapshot of the universe as it was in its infancy. When it first shone, the universe was a fiery 3,000 degrees Kelvin. But as space expanded over eons, stretching this primordial light to longer and cooler wavelengths, it faded to the faint microwave glow we detect today, just 2.7 degrees above absolute zero. It's humbling to realize that every photon of this ancient light has been traveling for over 13 billion years to reach us. In a sense, when we look at the cosmic microwave background, we're seeing the ultimate baby picture of the universe. It's a visual echo of the Big Bang itself, and a reminder of how far the cosmos has come in the eons since. But the early universe wasn't done transforming yet. In fact, the period of expansion right after the Big Bang may have been even more dramatic than the Big Bang itself. In the 1980s, a young physicist named Alan Guth proposed a remarkable idea called cosmic inflation, a brief burst of exponential expansion in the first fraction of a second of the universe's existence. According to inflation theory, in the tiniest sliver of time after the universe was born, space underwent a growth spurt like no other. It doubled in size every 10 to the negative 34 seconds, expanding faster than the speed of light. In an eye blink, the observable universe went from smaller than a proton to macroscopic size. This might sound impossible, after all nothing can move through space faster than light. But inflation wasn't about moving through space, it was space itself expanding. There's no speed limit on the expansion of the universe itself. In fact, even today, there are distant galaxies being carried away from us by the expansion of space faster than the speed of light. Their light will never reach us. They've crossed the cosmic horizon, the ultimate boundary between the observable and unobservable universe. Inflation was so dramatic that it pushed most of the universe, in fact most of reality as we know it, forever beyond our view. If inflation is correct, our observable universe is just a tiny island in an unimaginably vast sea of space, most of it permanently out of our reach. It's a bit like a ship on the ocean. We can only see to the horizon, but we know there's much more ocean beyond our view. In the case of the universe, inflation has pushed most of that ocean far beyond the cosmic horizon. But why did the universe inflate so dramatically? What drove this incredible burst of expansion? That's still a mystery. But inflation does seem to solve some long-standing cosmic conundrums. For example, when we look out into space on the larger scales, we see something remarkable. The universe is almost perfectly smooth. On average, one region of the observable universe has roughly the same density and composition as any other region. This is quite puzzling. How did these vastly distant regions, which are now out of contact with each other, manage to coordinate their properties? Inflation offers an answer. Before inflation, the observable universe was microscopically small, allowing every region to mingle and equilibrate. As inflation kicked in, and these regions were flung far apart faster than light, they carried the echo of their primordial connection with them. A smoothness established in the infant universe became locked in, as inflation catapulted these regions beyond the cosmic horizon. Inflation also explains another strange property of the universe, its flatness. When we measure the geometry of space on the larger scales, it appears to be perfectly flat. Parallel lines remain parallel forever. They never curve together or apart. But this flatness is very unstable, like a pencil balanced precariously on its tip. Any deviation from perfect flatness in the early universe should have grown over billions of years, resulting in a highly curved universe today. But that's not what we see. Space is still uncannily flat. How can this be? Once again, inflation provides a solution. The rapid stretching of space during inflation would have diluted any curvature, flattening the universe out like pulling on a wrinkled sheet. What we're left with is a cosmos that's almost perfectly geometrically flat, a legacy of that early inflationary episode. Inflation even planted the seeds for everything we see in the universe today, from galaxies and stars to planets and people. According to quantum physics, even empty space is never truly empty. It's always flickering with tiny energy fluctuations, popping particles in and out of existence. During inflation, these quantum ripples were stretched to macroscopic scales, becoming subtle density variations spread throughout space. Over eons, these primordial density variations grew under gravity, with slightly denser regions attracting more and more matter. Eventually, some regions reached a critical density and collapsed to form the first stars and galaxies, lighting up the cosmos. In a very real sense, the large-scale structure of the universe, with its sprawling cosmic web of galaxies and vast voids, all grew from quantum seeds stretched by inflation. It's incredible to think about that the largest structures in the universe, spanning hundreds of millions of light-years, all came from subatomic quantum flickers blown up by the rapid expansion of space. We are, each of us, the product of these primordial quantum fluctuations. Every atom in our bodies can trace its history back to those first moments after the Big Bang. But as mind-boggling as inflation is, it pales in comparison to the idea it gave rise to, the multiverse. You see, most versions of inflation theory suggest that inflation never truly ends, that even as our observable universe grew from an inflating patch of space, other patches were doing the same, sprouting like bubbles in a sea of eternally inflating spacetime. Each of these patches could become a universe in its own right, with its own physical properties. Some might have more dimensions than ours, others might have different types of particles or forces. In this view, our universe is just one island in an archipelago of universes, a cosmic bubble bath of unimaginable proportions. This idea, called the multiverse, is still highly speculative. But if it's correct, it has profound implications for our understanding of reality. It would mean that everything we've ever known, all the stars and galaxies in our observable universe, is just a tiny sliver of a much vaster multiverse. Our universe would be one grain of sand on an endless beach, one bubble in an eternal foam. The philosophical implications are staggering. Is there a copy of you reading this in another universe right now? Are there universes where life never took hold, or where the laws of physics are so different that stars and galaxies could never form? The multiverse opens up a dizzying array of possibilities. Of course, we have to be careful not to let our imaginations run too wild. The multiverse is still a highly speculative idea, and we may never have direct evidence for other universes. By definition, they would be causally disconnected from us, meaning no light or information could ever pass between them and us. For now, the multiverse remains firmly in the realm of theory. But even if we restrict ourselves to the observable universe, the one patch of space-time we can actually see, there are still so many wonders to explore, from the birth and death of stars to the colliding of galaxies and the warping of space-time by black holes. And as we peer further back in time to the earliest moments of the Big Bang, we're pushing the boundaries of known physics, probing realms of energy and density we can barely imagine. It's amazing to think about how far we've come in our understanding of the universe. Just a century ago, we thought the Milky Way was the entire universe. Now we know it's one of trillions of galaxies in an expanding cosmos that's been evolving for nearly 14 billion years. We've traced the history of the universe back to the first seconds after the Big Bang, and we're starting to piece together clues about what came before. But there's still so much we don't know, so many mysteries waiting to be unlocked. What exactly happened at the moment of the Big Bang? What drove inflation, and did it give rise to a multiverse? What is the nature of dark matter and dark energy, the invisible stuff that seems to dominate the cosmos? And perhaps most profoundly, why is there something rather than nothing? Why does the universe exist at all? These are the questions that keep cosmologists up at night. They're the questions that have driven thinkers like Georges Lemaitre and Alan Guth to devote their lives to studying the universe, and they're the questions that will continue to inspire and perplex us as we push the boundaries of cosmic knowledge. But for now, as we drift off to sleep under the canopy of the night sky, we can take a moment to marvel at the universe we find ourselves in. We can trace the graceful arc of the Milky Way across the sky and know that we're seeing the light of 100 billion stars. We can think about the countless galaxies pinwheeling through the inky depths of space, each one an island universe unto itself, and we can ponder the deep mysteries that still await us, the secrets hidden in the far reaches of space and time. In a very real sense, to study the universe is to study ourselves. We are, after all, creatures of the cosmos, our atoms forged in the crucibles of long-dead stars. When we gaze up at the night sky, we're not separate from the universe. We're part of its grand, unfolding story. So as we close our eyes and surrender to sleep, we can carry that cosmic perspective with us. We can remember that even in our dreams, we're still children of the stars, forever linked to the vast and wondrous universe that gave us birth. And perhaps as we drift off, we can smile at the thought that somewhere out there, the universe is dreaming too, dreaming through us and through all the living things that call it home. Good night, and may your dreams be as vast and wondrous as the cosmos itself. As we ponder the vast expanses beyond our cosmic horizon, it's humbling to realize that our observable universe is but a small island in an unimaginably large cosmos. The expansion of space itself ensures that much of the universe will remain forever beyond our reach, receding faster than the speed of light. It's a poignant reminder of our tiny place in the grand scheme of things. But even within our observable universe, there's still so much to explore and discover. As we gaze out into the night sky, we're looking back in time, seeing distant galaxies as they were billions of years ago, their ancient light traversing the vast gulfs of space to reach our eyes. It's a breathtaking thought that we can directly observe the universe's past all the way back to the afterglow of the Big Bang itself. That afterglow, the cosmic microwave background, is a treasure trove of information about the early universe. Encoded in its faint glow are the seeds of cosmic structure, the tiny density variations that would eventually give rise to galaxies, stars, and planets. It's amazing to think that everything we see around us, including our own Earth and our own bodies, can trace its origins back to quantum fluctuations in the universe's infancy. And if the theory of cosmic inflation is correct, those quantum fluctuations were stretched to cosmological scales by the universe's incredible exponential expansion in its first fraction of a second. Inflation is a mind-bending idea, that the universe could have expanded faster than the speed of light, pushing most of its volume forever beyond our view. It's a humbling thought, to realize that our entire observable universe may be just a tiny bubble in an eternally inflating multiverse. The multiverse is a concept that stretches the limits of our imagination. To think that our universe, with its hundreds of billions of galaxies and unimaginable vastness, could be just one of countless bubble universes sprouting from the quantum foam of a greater multiverse. It's almost too much to wrap our minds around. But it's a possibility that some of the greatest thinkers of our time are seriously considering. One of those thinkers was Andrei Lind, a Russian-American theoretical physicist who made groundbreaking contributions to the theory of cosmic inflation and the multiverse. Born in Moscow in 1948, Lind fell in love with physics at an early age and excelled in his studies, earning a PhD from the Lebedev Physical Institute in 1975. His early work focused on particle physics and quantum field theory, but he soon became fascinated by cosmology and the big questions about the origin and evolution of the universe. In the early 1980s, Lind began developing his ideas about inflation and the multiverse. Building on the work of Alan Guth and others, Lind proposed that inflation could be an eternal process, with quantum fluctuations causing new bubble universes to continuously sprout from the inflating spacetime. Each of these bubble universes could have different physical properties and constants, giving rise to a vast and diverse multiverse. Lind's ideas were revolutionary, and not everyone in the physics community was ready to accept them. The concept of a multiverse seemed like science fiction to some, untestable and untethered from reality. But Linda persisted, refining his theories and arguing persuasively for their merits. His 1986 paper, Eternally Existing, Self-Reproducing, Chaotic Inflationary Universe, became a seminal work in the field. Over the decades, Linda continued to be a leading voice in the study of inflation and the multiverse. His ideas have influenced a generation of cosmologists and sparked countless hours of debate and discussion. Today, the theory of eternal inflation and the multiverse, while still speculative, is taken seriously by many of the world's top physicists. Looking back on Linda's career, it's inspiring to see the impact that one curious and creative mind can have. By daring to ask the big questions and follow the math wherever it led, Linda helped us to expand our understanding of the universe and our place within it. His work reminds us that even the most far-out ideas, if grounded in solid science, can lead to incredible breakthroughs. As we continue to explore the mysteries of the cosmos, it's good to keep an open mind and a sense of wonder. The universe is often stranger and more amazing than we can imagine, and the theories we cling to today may one day be superseded by even more astonishing ideas. The eternal inflation and multiverse theory may be one such idea, a mind-blowing concept that, if true, would mean our universe is just one humble bubble among an infinity of others. But even if we are alone in our bubble, our universe is still an incredible place. As we look to the far future, we can imagine the cosmos continuing to evolve and change in ways we can scarcely imagine. Galaxy clusters will merge and grow under the relentless pull of gravity, while dark energy pushes the space between them ever wider. The expansion of the universe will accelerate, causing distant galaxies to recede beyond our cosmic horizon until only our local supercluster remains visible. On even longer timescales, the universe will continue to cool and dim as the last stars exhaust their fuel and wink out one by one. Eventually only darkness will remain, a void dotted with black holes and the fading embers of stellar remnants. And in the unimaginably distant future, even black holes will evaporate, their energy slowly dissipating into the void until the universe reaches a state of maximum entropy, the heat-death scenario. It's a poetic and melancholy vision, the universe winding down to a cold, dark and quiescent state over eons beyond imagining. But there's a strange beauty in that long, slow fade into darkness. It's the beauty of a universe that has run its course, that has given rise to an incredible flowering of complexity and consciousness before gently subsiding into eternal rest. And who knows? Perhaps in that unimaginably distant future, long after our own universe has gone dark, new universes will be born from the quantum foam, each one a new experiment in cosmic evolution, each one a new canvas upon which the fundamental forces can paint their masterpieces. The multiverse may be eternal and infinite, an endless cycle of birth, growth, and decay playing out over vast scales of space and time. These are the thoughts that fill our minds as we gaze up at the night sky, marveling at the beauty and mystery of the cosmos. We are the universe becoming aware of itself, contemplating its own existence through the unlikely medium of conscious matter. It's a profound and humbling realization, one that puts our own lives and concerns into perspective. So as you drift off to sleep, let your mind wander to the farthest reaches of space and time. Ponder the incredible journey of discovery that has brought us to this point, and the amazing insights of thinkers like Andre Linde who have helped to expand our cosmic horizons. Remember that even in an eternally inflating multiverse, filled with countless bubble universes beyond our reach, our own universe is still a wondrous and precious place. And most of all, never lose that sense of curiosity and wonder that draws us to the big questions. Keep dreaming, keep exploring, and keep reaching for the stars. Because in a universe as vast and mysterious as ours, there will always be new frontiers to explore, new mysteries to unlock, and new beauty to behold. Good night, and may your dreams be as boundless as the cosmos itself. As we ponder the vast expanse beyond our cosmic horizon, it's humbling to consider the groundbreaking thinkers who first glimpsed the true scale of our universe. In the early 20th century, an astronomer named Henrietta Swan Leavitt made a discovery that would change our perspective forever. Leavitt was born in 1868 in Massachusetts, at a time when women were often discouraged from pursuing scientific careers. Despite this, she developed a deep fascination with the stars from a young age. After graduating from Radcliffe College, she began work at the Harvard College Observatory as a computer, one of several women hired to perform complex mathematical calculations. It was tedious work, but Leavitt had a keen eye and a brilliant mind. While studying photographic plates of the Magellanic Clouds, two nearby dwarf galaxies, she noticed something peculiar about the stars known as Cepheid variables. These stars pulsate in a regular rhythm, growing brighter and dimmer over the course of days or weeks. As Leavitt carefully catalogued the brightness and pulsation periods of these stars, a remarkable pattern emerged. She realised that the slower Cepheid variable pulsed, the brighter it was. This meant that by measuring a Cepheid's pulsation period, one could deduce its intrinsic brightness. If you then compared this to its apparent brightness in the sky, you could calculate its distance from Earth. It was a breakthrough that would become known as the period-luminosity relationship, or Leavitt's law. But its true power wouldn't be recognised until a decade later, when Edwin Hubble used Cepheid variables as standard candles to measure the distances to faraway galaxies. By doing so, he discovered that our universe was far larger than previously imagined, and forever shattered the notion of a small static cosmos. Leavitt's discovery provided astronomers with a crucial tool for measuring the scale of the universe, paving the way for Hubble's groundbreaking work. Her story is a testament to the power of curiosity, dedication, and meticulous observation. Despite working in relative obscurity and receiving little recognition in her lifetime, Leavitt's contributions laid the foundation for modern cosmology. As we drift further out in space and time, it's easy to feel small and insignificant against the vastness of the cosmos. But Leavitt's work reminds us that even seemingly minor discoveries can have an outsized impact on our understanding of the universe. Her story invites us to look at the world with fresh eyes, to seek out patterns and connections that others might overlook. One can imagine Leavitt late at night, poring over photographic plates by candlelight, her tireless work fueled by a deep sense of wonder. Did she have any inkling of the revolution her discovery would spark? Could she ever have imagined that her careful cataloguing of variable stars would one day help us map the cosmos on the grandest of scales? Like the Cepheid variables she studied, Leavitt's legacy pulsates through the history of astronomy, growing brighter with each passing year. Her work reminds us that the universe reveals its secrets not only in grand, sweeping gestures, but also in the quiet, dedicated efforts of those who seek to understand its workings. As we continue our journey to the edge of the observable universe and beyond, let us carry with us the spirit of Henrietta Leavitt, a spirit of curiosity, perseverance, and a deep reverence for the mysteries of the cosmos. For even as we strain to see beyond our cosmic horizon, we stand on the shoulders of giants whose insights light the way forward. And so, as we drift off to sleep, let us dream of the countless wonders that await us in the vast expanse of space and time. May we approach the universe with the same sense of awe and determination that guided Leavitt's work, knowing that even the smallest steps can lead to the greatest of discoveries. In the grand tapestry of the cosmos, we are but a tiny thread, but oh, what a glorious and intricate pattern we are woven into. As we contemplate the edge of our observable universe and the infinite possibilities that lie beyond, let us find comfort in the knowledge that we are part of an endlessly fascinating and beautiful whole. So let your mind wander to the farthest reaches of space, to the very beginning and end of time. Let the gentle pulsations of distant stars lull you into a peaceful slumber, secure in the knowledge that you are an integral part of this vast and wondrous universe. And as you drift off to sleep, carry with you the spirit of all those who have dedicated their lives to unravelling its mysteries, a spirit of wonder, perseverance, and an unshakable faith in the power of human curiosity. Sweet dreams, dear listener, and may your cosmic horizons be ever expanding. The work of Henrietta Swan Leavitt and other early astronomers laid the groundwork for our modern understanding of the universe's true extent. But as we've seen, there's still so much we don't know about what lies beyond the edge of our observable bubble. Could there be other universes out there, forever hidden from our view? It's a question that continues to captivate some of today's most brilliant minds. In the 1980s, a young physicist named Andrei Linde began to develop a radical new theory about the origin and nature of our universe. Born in Moscow in 1948, Linde was a precocious child who excelled in mathematics and physics. His prodigious talent earned him a place at Moscow State University, where he studied under the renowned Soviet physicist Vitaly Ginzburg. It was a time of great excitement and discovery in cosmology. Just a few years earlier, physicists had detected the cosmic microwave background radiation, the afterglow of the Big Bang that had been predicted by George Gamow and others. This discovery had confirmed that our universe had a beginning, and sent theorists scrambling to understand the details of how it all began. Lind was particularly intrigued by the idea of cosmic inflation, which had been proposed by Alan Guth in 1980. Guth's theory suggested that in the first fraction of a second after the Big Bang, the universe underwent a period of exponential expansion, doubling in size every 10 to the negative 34 seconds. This rapid expansion could explain many of the universe's observed properties, such as its smoothness and flatness. But as Lind studied the equations of inflation, he began to suspect that the story was even more bizarre and wonderful than Guth had imagined. In a series of groundbreaking papers in the 1980s, Lind proposed a new model called eternal chaotic inflation. According to this theory, inflation wasn't just a one-time event in our universe's history. It was a never-ending process that continuously spawned new, bubble universes. The implications were staggering. If Linda was right, our universe was just one of countless bubbles floating in an eternally inflating sea, a vast multiverse of unimaginable proportions. Each bubble could have its own unique properties, governed by different physical laws and constants. Some might be teeming with complex structures and life, while others might be barren and inhospitable. It was a vision of reality that challenged our most fundamental assumptions about the nature of the cosmos. But Linda's ideas weren't just wild speculation. They were grounded in rigorous mathematical analysis and consistent with the laws of quantum mechanics. His work helped to launch a new era of cosmological theorizing, as physicists grappled with the possibility of a multiverse that dwarfed even our wildest imaginings. Today, the idea of the multiverse remains controversial and unproven, but it continues to captivate the imaginations of scientists and laypeople alike. There's something both humbling and exhilarating about the notion that our universe might be just one tiny bubble among infinitely many, a cosmic grain of sand on an endless beach of possibilities. As we lie here in the darkness, our minds adrift in the vastness of space and time. It's easy to feel small and insignificant in the face of such immensity, but perhaps there's a strange sort of comfort in that smallness. A reminder that we are part of something much grander and more mysterious than we can ever fully comprehend. And so, as we ponder the edge of our own cosmic bubble and the infinite realms that may lie beyond, let us embrace the sense of wonder and possibility that Linda's vision evokes. Let us dream of the strange and marvellous universes that may be lurking just out of view, each one a testament to the breathtaking creativity and diversity of nature. In the end, perhaps it doesn't matter whether we can ever directly observe these other realms. What matters is the way they stretch our imaginations and challenge us to think beyond our everyday experience. They remind us that the universe is always vaster, stranger, and more beautiful than we can possibly imagine, and that the quest to understand it is an endless source of wonder and delight. So let your mind drift to the farthest reaches of the multiverse, dear listener. Let Linda's vision of an endlessly bubbling cosmos be the backdrop for your dreams. And know that wherever your journeys take you, in this universe or any other, you are part of a grand and glorious unfolding that surpasses our wildest imaginings. Good night, and may your dreams be as vast and wondrous as the cosmos itself. As we ponder the vast expanse beyond our cosmic horizon, it's humbling to think about how much of the universe remains hidden from our view. Our observable bubble is but a tiny island in the grand cosmic ocean, a mere 46 billion light-years across. And yet, even within this limited sphere, the sheer scope and majesty of the cosmos is enough to inspire wonder and curiosity that can last a lifetime. Just think, the light reaching us from the most distant galaxies we can see has been travelling for billions of years, a journey that began long before Earth even existed. Those ancient photons have borne silent witness to the birth and death of countless stars, the formation and evolution of whole galaxies, as they streamed across the ever-expanding fabric of space. And still, they are merely the forerunners, the vanguard of an even grander procession of light that we may never glimpse. It's a staggering thought, one that astronomers like Edwin Hubble could scarcely have imagined when they first turned their telescopes to the night sky in the early 20th century. Hubble, a brilliant yet unassuming man, had already lived a full life by the time he made his groundbreaking discoveries. Born in Missouri in 1889, he was a gifted athlete and scholar, excelling in track and field, physics, and even literature and law, but it was in astronomy that he found his true calling. Working at the Mount Wilson Observatory in California, Hubble had access to the most powerful telescope of his day, the 100-inch Hooker reflector. Night after night, he trained this enormous eye on the heavens, meticulously cataloguing and classifying the fuzzy nebulae he observed. At the time, most astronomers believed these nebulae were relatively nearby clouds of gas and dust within our own Milky Way galaxy. But Hubble's keen observations would soon shatter that assumption. In 1923, Hubble identified a special type of pulsating star called a Cepheid variable in one of these nebulae, the Andromeda Nebula. Cepheids are invaluable cosmic beacons. Their pulsation rate is directly related to their intrinsic brightness, so by timing their light variations, astronomers can deduce their true luminosity. Comparing this to their apparent brightness allows their distance to be calculated. When Hubble did this for the Cepheids in Andromeda, the result was staggering. The nebula was nearly 1,000,000 light-years away, far beyond the bounds of the Milky Way. Andromeda wasn't a nebula at all, but a whole other galaxy, what we now call the Andromeda Galaxy. This discovery forever changed our conception of the universe. No longer was our galaxy the entirety of creation. Instead, it was just one island universe, among countless others floating in the vast cosmic sea. But Hubble wasn't finished. Continuing to measure the distances to dozens of other galaxies, he made an even more astonishing finding. The farther away a galaxy was, the faster it appeared to be moving away from us. The light from these distant galaxies was shifted towards the red end of the spectrum, a telltale sign of recession. This relationship between distance and recession speed became known as Hubble's law, and pointed to a remarkable conclusion. The universe itself was expanding. The space between galaxies was stretching, carrying them apart like raisins in a rising loaf of bread. It was an insight of tremendous significance, one that would later be woven into the tapestry of cosmic history, as we came to understand the universe's origin and evolution. But beyond the realm of scientific discovery, Hubble's findings also evoked a deep sense of loneliness, of poignant isolation. If the universe is expanding, and the farther things are, the faster they recede, then doesn't that imply that distant regions will eventually be carried away faster than the speed of light? That as the eons unfold, more and more of the cosmos will slip beyond our view, vanishing across the cosmic horizon, never to be seen again by us or our descendants? It's a melancholy thought, one that Hubble himself may have contemplated in his later years. After a lifetime of peering into the depths of space and time, of charting the grandest structures of the cosmos, perhaps he felt the weight of all those vanishing stars and galaxies, all that unreachable majesty. One can imagine him looking up at the night sky, knowing that even as he watched, innumerable worlds were slipping away, their light and beauty forever lost to human eyes. As you lie in bed, your mind adrift in the currents of cosmic reverie, it's hard not to feel a similar sense of poignant wonder. The universe is so inconceivably vast, so much of it already lost to our view, and yet we are here, conscious and curious, able to trace its history and ponder its mysteries. In the darkness behind your eyelids, you can almost picture all those distant galaxies, their brilliant stars and swirling nebulae, all the alien worlds and civilizations they might contain, rushing away into the inky depths. How many trillions of sunsets have those unseen planets witnessed? How many stories have unfolded beneath those foreign stars? All those sagas of struggle and triumph, love and loss, playing out across eons on worlds we may never know. And yet, even as the cosmos expands and the light of distant suns fades from view, we are not alone. We have the legacy of thinkers like Edwin Hubble to keep us company, the fruits of their curiosity and brilliance to light our way. And we have the knowledge that we are a part of this vast and venerable universe, our atoms forged in the crucibles of ancient stars, our consciousness a way for the cosmos to know itself. As sleep begins to soften the edges of your thoughts, let your mind drift out beyond the cosmic horizon, to the farthest reaches of space and time, and know that you are part of the grandest story ever told, a story that will continue to unfold long after we are gone, in realms and realities we can scarcely imagine. But for now, Let the lull of the expanding universe carry you into the waiting embrace of dreams. Let your waking mind release its hold on the here and now and set your imagination adrift in the currents of infinity. There will be time enough to ponder the mysteries that remain, to chase the light of distant stars and galaxies as they recede into the vast and venerable night. For now it is enough to know that we are here, alive and awake in this brief and shimmering moment, our hearts filled with wonder at the scale and splendour of it all. Rest now, and dream of the journeys yet to come, the secrets yet to be revealed in the glorious, ever-unfolding story of our universe. As we prepare to venture even deeper into the cosmos and its history, to explore the earliest eras of the universe's existence, it's worth pausing for a moment to appreciate how far our understanding has come. For most of human history, the true nature and scale of the universe were shrouded in mystery, the subject of myth and speculation. Our ancestors looked up at the night sky and saw a fixed, eternal realm, a celestial sphere that revolved around the Earth, which they believed to be the centre of all creation. It was only through centuries of careful observation, mathematical calculation, and intellectual daring that this parochial view began to crumble. Visionaries like Copernicus and Galileo showed that the Earth was not the centre, but rather orbited the Sun along with the other planets. Later thinkers like Newton and Laplace established the physical laws that govern the motions of celestial bodies, revealing a cosmos of astonishing regularity and precision. And with the advent of ever more powerful telescopes, the true depth and diversity of the universe began to come into focus. A universe filled with countless stars, nebulae, and galaxies extending in all directions to unimaginable distances. But even as our view of the cosmos expanded, the question of its origin remained. How did this vast and intricate universe come to be? Was it eternal and unchanging, as many philosophers had long believed? Or did it have a beginning, a moment of creation? It was a question that would occupy some of the 20th century's greatest scientific minds, and ultimately lead to a radical reimagining of the universe and our place within it. At the forefront of this revolution was a brilliant and unassuming Belgian priest named Georges Lemaitre. Born in 1894, Lemaitre was a man of many talents, a gifted mathematician, a skilled astronomer, and a deeply spiritual thinker who saw no conflict between his scientific pursuits and his religious faith. In fact, he believed that the study of the universe was a way to glimpse the mind of the Creator, to marvel at the intricacy and beauty of the cosmic design. Lemaitre's groundbreaking work began in the 1920s, when he was a young graduate student studying physics and astronomy. At the time, the prevailing view among scientists was that the universe was static and eternal, a vast and unchanging arena in which celestial bodies moved according to fixed, immutable laws. But Lemaitre, with his keen mathematical mind and his deep intuition for the workings of nature, saw something different. Delving into Einstein's recently published theory of general relativity, which described gravity as a curvature in the fabric of spacetime, Lemaitre realized that the equations allowed for a universe that was not static but dynamic and evolving. In fact, as he worked through the mathematics, he found that the universe could not be static at all. It had to be either expanding or contracting. This was a startling conclusion, one that flew in the face of centuries of scientific and philosophical tradition. But Lemaitre was convinced he was onto something. In 1927, he published a paper titled A Homogeneous Universe of Constant Mass and Increasing Radius, accounting for the radial velocity of extragalactic nebulae. A mouthful of a title that would come to be recognized as one of the seminal works of modern cosmology. In this paper, Lemaitre proposed a model of the universe that began as a single point, what he called the primeval atom, and then expanded and evolved over time. He showed how this model could account for the observed recession of distant galaxies, which had recently been discovered by Edwin Hubble, and he even derived a mathematical relationship between a galaxy's distance and its recession speed that was remarkably similar to what Hubble would later establish. It was a bold and visionary idea, one that required a leap of imagination and a willingness to challenge long-held assumptions. But for Lemaitre, it was also a deeply satisfying convergence of his scientific and spiritual convictions. In the primeval atom, he saw echoes of the biblical creation story, a moment of divine origin from which the universe unfolded in all its complexity and grandeur. And in the ongoing expansion of the cosmos, he saw evidence of a dynamic and purposeful creation, a universe imbued with meaning and direction. Of course, not everyone was convinced by Lemaitre's ideas. Many of his contemporaries, including Einstein himself, were initially skeptical of the notion of an expanding universe, preferring to believe in a cosmos that was eternal and unchanging. But as evidence continued to mount, from Hubble's observations of galactic recession to the discovery of the cosmic microwave background radiation, the idea of a dynamic, evolving universe gradually gained acceptance. Today we know that Lemaitre's intuition was correct. The universe did have a beginning, a moment of creation that we now call the Big Bang, and in the decades since Lemaitre's pioneering work, we have traced the evolution of the cosmos back to its earliest moments, to the forging of the first atoms and the seeds of cosmic structure. But as we lie here in the darkness, our minds adrift in the currents of cosmic history, it's worth reflecting on the deeper significance of Lemaitre's vision. In a universe that began as a single point and has been expanding and evolving ever since, we are all, in a sense, the products of that primeval atom. The atoms that make up our bodies, the stars and planets that fill our skies, the very fabric of space-time itself, all of it can be traced back to that initial moment of creation. And yet, even as we marvel at the grandeur and complexity of the universe, we are also reminded of our own smallness, our own fleeting existence in the vast sweep of cosmic time. Lemaitre himself, for all his brilliance and insight, lived a relatively brief life, passing away in 1966 at the age of 71. But his ideas, his vision of a dynamic and purposeful universe, live on, inspiring new generations of thinkers and explorers to probe the mysteries of the cosmos. As you drift off to sleep, let your mind wander back to that primeval atom, to the birth of space and time and all the wonders that would unfold from it. And remember that you too are a part of that grand cosmic story, a child of the stars and the Big Bang, a conscious witness to the awesome majesty of the universe. Rest now and dream of the mysteries yet to be revealed, the secrets of the cosmos that await our discovery. For in the end, the story of the universe is also the story of us, of our endless quest to understand our place in the grand scheme of things, and to marvel at the beauty and complexity of the world we inhabit. Having explored the universe's distant past and the possibility of a greater multiverse, let's turn our gaze to the far future. The universe we inhabit today, filled with hundreds of billions of galaxies, each shining with the light of countless stars, feels eternal and unchanging. But like a cosmic clock ticking on nearly unimaginable timescales, the future of our universe is one of gradual yet profound transformation. In the coming eons, gravity will continue its patient work, drawing galaxies together into ever larger structures. Our own Milky Way is destined for a collision with our nearest neighbour, the Andromeda Galaxy, in about 4 billion years. The two spiral galaxies will dance around each other in a majestic swirl of starlight, their individual stars far enough apart to avoid collision, until they eventually merge into a single, larger elliptical galaxy. On even greater scales, galaxy clusters will continue to grow, as smaller groups and individual galaxies fall inwards and merge with these titanic structures. The Virgo supercluster, of which our local group is a part, will eventually combine with other nearby superclusters like Hydra Centaurus and Pavo Indus to form a structure spanning nearly 1 billion light-years. But even as gravity draws these vast cosmic archipelagos together, another force is at work on the grandest scales. Dark energy, the mysterious force that makes up about 68% of the universe's total energy and matter content, is causing the expansion of the universe to accelerate. Like a cosmic anti-gravity, dark energy pushes space itself apart from within. As the universe continues to expand and dark energy continues to push ever harder, an increasing fraction of galaxies will begin to recede from us faster than the speed of light. The light from these distant structures will become increasingly redshifted, eventually sliding out of the visible spectrum and into the infrared, microwave and radio bands as they cross our cosmic horizon and disappear from view forever. Eventually, in 100 billion years or more, the persistent push of dark energy will leave only local clusters of galaxies gravitationally bound, like lonely islands in a vast and ever-widening cosmic ocean. The rest of the universe will be carried beyond our view, even galaxies we can see now, their light and existence erased and inaccessible to us, orphaned by the relentless expansion of space itself. This idea of an island universe, a cluster of galaxies isolated by cosmic expansion, was first proposed by American astronomer Harlow Shapley in the early 20th century. At the time, the true scale of the universe was a mystery, and the concept of island universes was a contentious topic of debate. Shapley himself argued against the idea, believing that the Milky Way was the entirety of the universe. It wasn't until the 1920s, with Edwin Hubble's observations of distant galaxies, that the island universe theory was confirmed, and our conception of the cosmos expanded once again. Shapley's contributions to astronomy extended far beyond the island universe debate. His research on globular clusters and his calibration of the period luminosity relationship of Cepheid variable stars allowed him to make the first reliable estimates of the size of the Milky Way and our Sun's position within it. In the famous Great Debate of 1920 with Heber Curtis, Shapley argued correctly for the vast size of our galaxy, but failed to anticipate the existence of countless other galaxies beyond our own. Nevertheless, his work helped pave the way for our modern understanding of the scale and structure of the cosmos. As the universe continues to expand and cool over countless eons, the formation of new stars will gradually taper off. In galaxies like our own, star formation will decrease as the interstellar medium becomes increasingly enriched with heavy elements from earlier stellar generations. These elements allow gas clouds to cool and fragment more efficiently, producing smaller, lower-mass stars. Eventually, in the far future of the universe, only these small, dim, long-lived stars will remain, steadily consuming their meagre hydrogen reserves over trillions of years. But even these ancient stellar embers will eventually fade. On timescales of 1 to 100 trillion years, the last stars will exhaust their fuel, collapsing into faint white dwarfs or exploding as supernovae, leaving behind neutron stars and black holes. The universe will enter a period known as the degenerate era, where no new stars are born to replace those that have died. Galaxies will become dark and quiescent, increasingly dominated by dark matter and the remnants of long-dead stars. Yet even this is not the end. In the far future of the degenerate era, on timescales of 10 to the power of 15 to 10 to the power of 37 years, even the stellar remnants will begin to fade. White dwarfs will cool and crystallize, their nuclear fires exhausted, becoming black dwarfs invisible against the void of space. Neutron stars will collide and merge, or decay into protons and electrons, and even the supermassive black holes at the centers of galaxies will slowly evaporate through the process of Hawking radiation, a quantum mechanical effect first proposed by Stephen Hawking in 1974. Hawking's groundbreaking work on black hole thermodynamics upended our understanding of these enigmatic objects. According to his calculations, black holes are not entirely black. They emit a faint stream of thermal radiation generated by quantum effects at their event horizons. For stellar mass black holes, this radiation is minuscule, and the evaporation process would take some 10 to the power of 67 years, vastly longer than the current age of the universe. But for microscopic primordial black holes thought to have formed in the early universe, Hawking radiation could cause them to evaporate explosively, providing a potential window into exotic gravitational phenomena. As the eons tick by and the universe continues to expand and cool, even the black holes will gradually decay into a thin soup of photons, neutrinos, electrons and positrons. Matter itself will begin to break down, as protons and neutrons decay into their constituent quarks, and then into leptons and radiation. In this epoch, known as the Dark Era, the universe will be a dilute, ever-expanding sea of fundamental particles and low-energy radiation, with no trace of the rich cosmic structures that once filled the cosmos. This bleak far-future scenario is known as the heat death of the universe, a state of maximum entropy where no useful energy remains to sustain motion or life. It is a poetic and melancholy notion, the idea that the universe will eventually exhaust its reserves of order and energy, decaying into a featureless void for all eternity. But there is a strange beauty in this ultimate fate, a reminder of the preciousness and fragility of the present moment and the structures and life the universe has managed to create and sustain. But even the heat death may not be the end. Some theories propose that random quantum fluctuations, occurring over vast time scales of 10 to the power of 10 to the power of 120 years, could trigger a new Big Bang, giving birth to a new universe rising phoenix-like from the ashes of the old. This notion of a cyclic or oscillating universe, where each cosmic cycle lasts a near eternity before giving way to the next, has ancient roots, appearing in Hindu cosmology as the days and nights of Brahma. In the 1920s and 30s, Richard Tolman and others explored the cyclic model through the lens of general relativity, but found that with each cycle, entropy would increase, resulting in longer and longer cycles until the universe reached a final heat-death state. More recently, Paul Steinhardt and Neil Turok proposed a cyclic model based on string theory and the collision of higher dimensional branes, but the ultimate fate of our universe remains an open question. As we ponder the far future, we're confronted with the immensity of time that our universe has before it. The current age of 13.8 billion years is but an eye blink compared to the trillions, quadrillions, and unimaginable eons that cosmic evolution will continue. It is a humbling and awe-inspiring realization, one that puts our fleeting human existence into a truly cosmic perspective. And yet, we are the universe becoming aware of itself. These speculations and discoveries are the products of the same cosmic evolution that will carry the universe into its far future. We are the matter of the cosmos, arranged into living, thinking beings capable of contemplating our origins, our destiny, and our place in the grand sweep of cosmic time. In that sense, we are the universe's way of knowing itself, a cosmic self-awareness that is both fleeting and precious. So as we drift off to sleep, let us hold that thought in our minds, that we are part of a grand cosmic story, a tale of evolution and discovery that stretches from the birth of the universe to its ultimate fate. The dreamers and thinkers that came before us, from ancient astronomers to Hubble, Hawking, and beyond, have guided us to this present understanding, sketching the outlines of the cosmos in ever greater detail. But the story is far from over. As we slumber, new discoveries are waiting to be made, new chapters to be written in the epic of cosmic exploration. We may be separated from the far future by unfathomable gulfs of time, but we are connected to it by the unbroken chain of cause and effect, the cosmic heritage of a universe unfolding according to the laws of nature. And so, as we let sleep overtake us, let us dream of the wonders yet to be discovered, the secrets yet to be unlocked in the grand cosmic drama of our universe. Let us be inspired by the thinkers and dreamers who came before us, and let us add our own verse to the great poem of the cosmos. For though the universe may be vast and our time within it fleeting, we are an essential part of its unfolding story, and that is a profound and beautiful thing. Good night, and may your dreams be filled with the wonders of the cosmos as we drift off to sleep beneath the canopy of our vast, mysterious, and endlessly fascinating universe. The universe continues far beyond the limits of what we can see. As we gaze up at the night sky, we're only glimpsing the tiniest sliver of the vast cosmic expanse. The observable universe stretches out some 46 billion light-years in every direction, containing hundreds of billions of galaxies, trillions of stars, and countless worlds. But this impressively large sphere is still just a small portion of the entire universe. The reason we can only see a limited distance is that the universe has a finite age. It began in the Big Bang about 13.8 billion years ago. In that time, light has only been able to travel a certain distance, roughly 46 billion light-years, accounting for the expansion of space. This sets a boundary on our observations, like a circular horizon centered on the Earth. Beyond that horizon, the universe continues, perhaps infinitely. We just can't see those distant reaches because their light hasn't had time to get to us. It's a staggering thought. The observable universe, as incomprehensibly huge as it is just an island in the vast cosmic ocean. Imagine standing on the shore, looking out at the waves extending to the horizon, knowing the ocean continues far beyond what the eye can see. The entire Earth, in all its diversity and scale, is like a grain of sand on that beach. That's the observable universe, a speck in the wider cosmos. This idea began to take shape about a century ago thanks to the tireless work of American astronomer Edwin Hubble. In the 1920s, while working at the Mount Wilson Observatory in California, Hubble began using the largest telescope in the world at the time, the Hooker 100-inch reflector, to peer at distant nebulae, or clouds in space. Some of these nebulae, like the Andromeda Nebula, had been observed by astronomers for centuries. but they were generally thought to be clouds of gas and dust within our own galaxy, the Milky Way. Hubble, however, noticed something peculiar about them. Using a special type of pulsating star called a Cepheid variable, Hubble was able to estimate the distances to these nebulae. To his surprise, they were incredibly far away, much farther than the size of the Milky Way. Hubble realized that these weren't nebulae within our galaxy at all. They were entire galaxies in their own right, each containing billions of stars. This was a transformative discovery. The universe was far bigger than anyone had imagined. Our Milky Way galaxy, once thought to be the entire universe, was just one of countless island universes dotting the cosmic sea. But Hubble's groundbreaking discoveries didn't stop there. As he studied the light from these distant galaxies, he noticed another peculiar thing. Their light was shifted toward the red end of the spectrum like the pitch of a receding train's whistle drops as it moves away from you. This redshift was greater for more distant galaxies. Hubble realized this was evidence that the galaxies were moving away from us, and not just that. The farther away a galaxy was, the faster it was receding. The universe wasn't static, but expanding. This revolutionary finding overturned the conventional wisdom of the time. The prevailing view was that the universe was eternal and unchanging, the steady-state model. But Hubble's data clearly showed that the universe was in fact dynamic and evolving. Hubble's observations led him to a profound conclusion, now known as Hubble's law. The universe is uniformly expanding, with galaxies moving away from each other like raisins in a rising loaf of bread. The greater the distance between any two galaxies, the faster they recede from one another. It was a stunning realization. The universe wasn't just unimaginably vast in space, it was also changing over time. And if you rewind the cosmic clock, playing the expansion in reverse, everything converges to a single point or singularity in the finite past. The implication was clear, though controversial at the time: the universe had a beginning. The idea of a universe with a finite age, born in a cosmic birth or Big Bang, represented a seismic shift in our understanding of the cosmos. It was a radical departure from the steady-state view. Though initially met with skepticism, the evidence mounted over the 20th century. The discovery of the cosmic microwave background in the 1960s, the leftover heat of the Big Bang, was a major confirmation of the theory. The static universe gave way to the idea of cosmic evolution, of a universe with a history unfolding over eons. As we'll explore, that evolutionary story has taken the universe from an infinitesimal speck to the vast expanse we see today, and carried much of its volume forever beyond our view. The Big Bang set cosmic expansion in motion, and in doing so it ensured that the observable universe would only ever be a small portion of the grander whole. But let's not get ahead of ourselves. To truly appreciate why we can only see a slice of the universe, we have to go back to the beginning, to the primordial fireball of the Big Bang itself, 13.8 billion years ago. Imagine the entire observable universe compressed into a volume smaller than an atom. That's the state of the cosmos in its first fraction of a second. Everything is squeezed into an infinitesimally small, searing hot, densely compressed point. At this moment, the four fundamental forces that govern the universe, gravity, electromagnetism, and the strong and weak nuclear forces, are unified as a single, immensely powerful force. The stuff of the universe is a seething, turbulent froth of energy, so hot that not even atoms can form. This is where the story of our universe begins, but the idea that the universe had a beginning was a radical one until the early 20th century. Scientists largely believed in an eternal and unchanging steady-state cosmos with no beginning or end. It took the insights of astronomer and physicist Georges Lemaitre to begin challenging that notion. Born in 1894 in Belgium, Lemaitre was both a devout Catholic priest and a brilliant scientist. In the late 1920s, he derived what became known as Hubble's law from Einstein's equations of general relativity, before Hubble did so observationally, showing that the universe must be expanding. Moreover, Lemaitre took this idea to its logical conclusion. If the universe is expanding, then it must have been smaller in the past, and if you rewind far enough, the entire universe would have been compressed into what he called the primeval atom, a single point from which the cosmos burst forth. It was a revolutionary idea. Lemaitre envisioned the birth of space and time in a now without yesterday, as he poetically put it. His primeval atom represented a physical beginning to the universe, a day without yesterday. Though Lemaitre's idea, which became known as the Big Bang theory, was initially met with skepticism, it gradually gained traction as evidence mounted. The discovery of the cosmic microwave background radiation in the 1960s was a major milestone, confirming a key prediction of the theory. Lemaitre's insights paved the way for the modern understanding of cosmic evolution. The universe began in an incredibly hot, dense state, around 13.8 billion years ago, and has been expanding and cooling ever since. The fundamental forces decoupled, particles formed, light elements coalesced, matter clumped into galaxies and stars, stars forged heavier elements, planets formed around second-generation stars, and on at least one such planet, life took root and eventually began to ponder its cosmic origins. It's a mind-expanding story, and one we'll explore in more depth. But the key point is that the universe has a history. It has evolved profoundly over eons, carrying the observable portion of the cosmos along with it as it expands. And most relevant to our question, the Big Bang means that the universe has a finite age. The cosmos may or may not be spatially infinite, but it is temporally finite. It had a beginning in time. And that means that light has only had a certain amount of time to travel. Light is the fastest thing in the universe, zipping along at about 300,000 kilometers per second. But even at that incredible speed, it still takes time to get from one place to another. The light from the Sun takes about 8 minutes to reach Earth. The light from Proxima Centauri, the nearest star beyond the Sun, takes 4.2 years to bridge the gap. On cosmic scales, the travel time for light is even more noticeable. The Andromeda Galaxy, our nearest major galactic neighbour, is about 2.5 million light-years away, meaning the light we see from it tonight left Andromeda 2.5 million years ago, when early hominins were just beginning to walk the plains of Africa. The most distant observable galaxies are billions of light-years away. Their light has journeyed for billions of years across expanding space to reach us. The light of the cosmic microwave background has been travelling for 13.8 billion years, since shortly after the Big Bang, before stars and galaxies had even formed. But there's a limit to how far we can see. Because the universe is 13.8 billion years old, light has only had 13.8 billion years to travel. There is a cosmic horizon, a boundary in space, beyond which we cannot see. Not because there's nothing there, but because the light from those regions hasn't had time to reach us yet. As far as we know, the universe continues on past that horizon. We have no reason to believe space just stops, but we can't directly observe those faraway reaches. They're cut off from our view, hidden beyond a veil of time and distance. When we gaze at the night sky, we're seeing a cosmic cross-section, a slice of the universe that's 13.8 billion years old in every direction. Telescopically, we can see back to about 400,000 years after the Big Bang, when the universe cooled enough for light to travel freely. Everything we see in the sky, from stars to galaxies to the cosmic microwave background, lies within our cosmic horizon. But the key thing to remember is that this horizon isn't fixed in space. It's fixed in time. The observable universe is the part of the universe that light has had time to reach us from since the Big Bang. As time goes on, the horizon expands, slowly unveiling regions that were previously too far for light to have reached us. In a sense, we're like archaeologists gradually uncovering a buried city. Each passing year, cosmic expansion lays bare a new layer of the universe that was previously beyond our view. The light from more distant regions finally completes its journey to our telescopes, but it's a slow process. The observable universe grows by 1 light-year per year, as light from slightly farther out finally reaches us. In 100 years, the radius of the observable universe will be 100 light-years larger. In 1,000,000 years, it will be 1,000,000 light-years larger. Still, there will always be a limit to what we can see, a cosmic horizon, beyond which the universe continues unexplored. The Big Bang set the clock ticking, and even at the speed of light, there's only so far the universe's age lets us see. It's a poignant thought. The observable universe is staggeringly vast, but it's still just a glimpse of a larger whole, most of it carried beyond our view by the arrow of time and the expansion of space. We're like castaways on an island, gazing out at an ocean that extends past the horizon, knowing there are distant lands we cannot see and may never visit. Edwin Hubble's groundbreaking observations in the 1920s not only revealed the existence of distant galaxies and the expansion of the universe, they also hinted at something even more profound: regions of the universe that are forever beyond our cosmic horizon. As Hubble studied the redshifts of distant galaxies, the signature of cosmic expansion stretching their light, he realized something remarkable. The farther away a galaxy is, the faster it's receding from us. This wasn't just an odd quirk, it was a fundamental feature of the universe. It became known as Hubble's law. Cosmic expansion carries galaxies away from each other, with more distant galaxies receding faster. At first glance, this seems to violate a cardinal rule of physics, that nothing can travel faster than the speed of light. How can distant galaxies possibly recede faster than this cosmic speed limit? The key is that the galaxies themselves aren't breaking the light barrier. Instead, it's the space between them that's expanding. The galaxies are like raisins in a rising loaf of bread. They're not zooming through space, but being carried along as the space they inhabit stretches out. And here's the thing, there's no limit to how fast space itself can expand. While matter and energy are constrained by the speed of light, space itself can stretch faster than light. It's not bound by the same rules. This means that beyond a certain distance, space is carrying galaxies away from us faster than the speed of light. From our perspective, those galaxies are receding so quickly that their light can never catch up to us. They've crossed a point of no return known as the cosmic event horizon. It's a mind-bending concept. There are regions of the universe that we can never see, not because they're too far away, but because they're being swept away from us too quickly for their light to ever close the gap. Even if we left today on a journey to one of these galaxies at the speed of light, we would never reach them. Space would be expanding ahead of us faster than we could travel through it. These galaxies are effectively lost to us, cut off by the relentless expansion of the universe. Their light is like a runner on a racetrack that keeps getting longer. The finish line recedes faster than the runner can sprint. For the most distant galaxies we can currently see, this cosmic event horizon is already just 5 billion light-years away, a distance that sounds immense, but is a mere stone's throw on cosmic scales. It's a poignant thought. As we look out into the universe, we're not just seeing distant galaxies, we're watching them slip away, and for the most distant reaches, that farewell is forever. The light from those galaxies will never reach us, even given an eternity to travel. They're sailing over the cosmic horizon, never to be glimpsed again from our shores. It's a natural consequence of living in an expanding universe that's a finite age. If the cosmos had no beginning, and galaxies were eternally receding, everything beyond our local group would already be forever lost from view. It's only because cosmic expansion has a starting point in the Big Bang that we can see as much as we do. But even that view is temporary. As the eons unfold, more and more of the universe will slip across the event horizon, winking out like receding ships sailing over the Earth's curvature. 100 billion years from now, all galaxies beyond our local group will have forever disappeared. The secrets of their stars, their worlds, their potential for life will be sealed away, carried off by the incessant tide of expanding space. It's a melancholy thought. We're afforded a brief glimpse of the cosmos, a fleeting window in which to drink in the majesty of the universe in its youth. But as time goes on, that view will narrow, the horizons will close in, and the rest of the universe will pass silently into the night, lost to us except as a fading memory. In this sense, we're profoundly fortunate. We've arisen as a species at a time when the observable universe is gloriously vast, with billions of galaxies strewn across billions of light-years still within our view. Future civilizations will survey an emptier, lonelier cosmos, with most of the universe's grandeur already stolen away by the ceaseless expansion of space. So as we ponder what lies beyond the edge of the universe, it's worth appreciating the slice of it that we can see. That cosmic horizon represents a poignant boundary, the limit of all we can ever know through direct observation, a reminder of how fleetingly we swim in the vast cosmic ocean. But it's also an invitation to wonder. In our mind's eye, we can voyage past that horizon, imagining the unseen vistas that lie beyond. The observable universe may be our entire world, but it's far from all there is. Our cosmic horizon is not a physical boundary, but rather the limit of how far light has travelled since the universe's fiery birth. As we peer across billions of light-years to the edge of the observable universe, we're looking back through time, seeing ancient light that set out eons ago and is only now reaching our telescopes. The nature of light itself sets this limit on our cosmic view. Though often described as the fastest thing in the universe, even light speed is not infinite. In the vastness of the cosmos, it can only travel so far over the universe's 13.8 billion year history. The most distant light we can see, coming to us from every direction, delineates a spherical boundary centered on Earth that we call the observable universe. But make no mistake, the observable universe is not all there is. Far from it. Beyond that boundary, the universe continues indefinitely, perhaps even infinitely. There are countless stars, galaxies, and wonders that we cannot see, not because they don't exist, but because their light has not yet had time to reach us. The observable universe is just our local patch, a finite sphere of space and time embedded in a far grander cosmos. It can be hard to wrap our minds around this cosmic horizon. When we look out into the night sky, it feels like we're seeing everything, but the truth is far more humbling. Imagine you're swimming in the middle of a vast, misty ocean, with a visibility of 100 meters in every direction. Beyond your little sphere of clarity, the ocean continues unabated, but you can't see it. Even if you had supremely acute vision, you couldn't see further than 100 meters through the mist. So your observable ocean is a sphere 200 meters across, centered on you. No matter where you swim, this sphere of visibility comes with you, but the vaster ocean is always there beyond it. Our observable universe is a bit like that, but on a grandly cosmic scale. The 46 billion light-year radius marks the distance that light could have travelled in the 13.8 billion years since the Big Bang. As the universe ages and light keeps propagating, we can see further and further, but there will always be a cosmic horizon, a frontier of the unknown, with uncharted realms beyond. The existence of this horizon speaks to how special light is. In our universe, nothing can outrun a light beam. You could race a photon across the cosmos with the fastest rocket ship imaginable, and you would still lose. Light is the ultimate speed limit, the velocity that sets the very rhythm and scale of causality and change in the cosmos. It's why the night sky is not a tapestry woven all at once, but a cascade of nested snapshots from across the eons. So in the darkness behind your closed eyes, as you drift towards sleep, ponder the peculiar fact that the observable universe is not static, but ever growing as light from distant realms finally reaches us after its long cosmic journey. With every passing second, photons that have been in flight for billions of years are plinking into telescopes and onto the retinas of wide-eyed stargazers. The boundary of the known is creeping ever outwards, bringing glimmers of new cosmic vistas into view. But it's not just astronomers and their instruments capturing this ancient light. When you look up at the stars blinking through the darkness, some of those photons have been crossing the cosmos since the time of the dinosaurs. They've passed through the depths of intergalactic space, shimmied through shimmering veils of dust and gas, and finally alighted in your eye after a journey of millions or billions of years. In a very real sense, stargazing is time travel sipping from the deep cosmic past. But even this grand revelation, that we are always peering into the universe's history, has a curious coda. Because the cosmos is expanding, there are stars whose ancient light will just barely reach us, their photons skirting across the observable universe like pebbles gliding along the surface of a pond. And there are other stars, perhaps innumerable, whose light has already missed the boat, destined to traverse an ever-widening cosmic gulf that will always outpace its velocity. In a strange and poetic way, the expansion of the universe is like a receding tide, steadily carrying away stars and galaxies in its ethereal currents. Over countless eons, more and more of the universe will slip over the cosmic horizon, never to be seen again from our vantage point. As space itself stretches between us and these distant realms, it will eventually be stretching faster than light, causing these luminous specks to flicker out of our observable domain like fireflies winking into the night. There's a profound loneliness to this picture, a cosmos where even the stars we hold dear will eventually recede into unseeable realms, their ancient light reaching into an empty sky. But there's also a breathtaking grandeur, a universe grander and more expansive than we can ever directly know, with our little oasis of stars hurtling through uncharted depths of space and time. In this view, even the darkness of night takes on a new meaning, not an empty void, but a frontier, rippling with the energy of an expanding universe that's carrying the most distant lights beyond our view. And so, as you settle deeper into your pillows, let your mind wander out to the edge of the observable universe and beyond. Picture the glittering tapestry of stars splayed out across the cosmos, some forever observable, some destined to slip away. Marvel at the fact that, even now, the most ancient light is still arriving, traversing those vast gulfs of space and time to paint our skies. And as your breathing deepens and sleep gathers around you like a warm cosmic blanket, take comfort in knowing that though the universe may be grander and more inscrutable than we can imagine, we are yet an integral part of its story. For our minds, our dreams, our ceaseless quest for knowledge, these too are expressions of the cosmos, as surely as stars and galaxies. So let the soft darkness cradle you, and dream of ancient starlight dancing across oceans of space and time, whispering the secrets of a universe vaster and more wondrous than we may ever know. The work of Edwin Hubble in the 1920s marked a turning point in our understanding of the cosmos. Hubble, born in Missouri in 1889, was an American astronomer whose groundbreaking observations would forever change our perception of the universe and our place within it. As a young man, Hubble studied math, astronomy and philosophy, nurturing a lifelong passion for unravelling the mysteries of the heavens. He served in World War I before completing his doctorate and beginning his career at the Mount Wilson Observatory in California. There, he had access to the most powerful telescope of its day, the 100-inch Hooker reflector. Night after night, Hubble would aim this mighty instrument at the sky, meticulously cataloguing and studying the faint, fuzzy nebulae that astronomers had puzzled over for centuries. Many believed these nebulae were relatively close clouds of gas and dust within our own Milky Way galaxy. But Hubble was about to make a discovery that would shatter that assumption and reveal the true immensity of the universe. Using the Hooker telescope, Hubble was able to resolve individual stars within several of these spiral nebulae, including the majestic Andromeda Nebula. To his surprise, he identified a type of pulsating star called a Cepheid variable, a standard candle whose intrinsic brightness could be determined based on its pulsation rate. By comparing the apparent brightness of these stars to their known luminosity, Hubble could calculate their distance. The results were staggering. The Cepheid variables, and thus the nebulae that contained them, were far too distant to be part of our Milky Way. Andromeda, Hubble determined, was a separate galaxy in its own right, one of many island universes populating the cosmos at inconceivable distances. The universe, it seemed, was vaster than anyone had dared to imagine, but Hubble's most profound discovery was yet to come. As he studied the spectra of light from dozens of distant galaxies, he noticed a curious pattern. The spectral lines of known elements were consistently shifted toward the red end of the spectrum, and this redshift was larger for fainter, more distant galaxies. It was as if the galaxies were universally rushing away from us, with more distant ones receding faster. The explanation for this lay in the work of Georges Lemaitre, a Belgian physicist and Catholic priest, who had proposed that the universe began in a primordial cosmic egg, and had been expanding ever since. Hubble's observations provided the first empirical evidence for this idea. The redshifts he observed were due to the stretching of light waves by the expansion of space itself. Hubble went on to plot the velocities of galaxies against their distances, finding a striking linear relationship that became known as Hubble's law. The farther a galaxy was, the faster it appeared to be receding from us. This was not due to the galaxies themselves moving through space, but the expansion of the space between them. The universe, Hubble showed, was not static but dynamic, constantly growing larger. The implications were profound. If the universe was expanding, then winding the clock backwards would imply a beginning, a definite moment when all matter and energy were compressed into an infinitesimal volume before rapidly dilating. The Big Bang Theory, as it would come to be known, had found its first observational support. Moreover, the expansion of the universe carried a poignant implication. At immense distances, the stretching of space would be so extreme that it would carry galaxies away from us faster than the speed of light. There would come a point where the light from these distant galaxies would never reach us, as the space it needed to traverse was expanding too rapidly. This boundary, known as the cosmic horizon, represented the ultimate limit of our view, a spherical shell of space, centered on us, roughly 46 billion light-years in radius. Light from beyond this shell, emitted in the distant past, was destined to remain forever out of sight, its source galaxies swept away by the relentless tide of expanding space. Hubble's discoveries painted a picture of a universe far grander and more expansive than we had ever conceived, an eternal stretching fabric of space-time, dotted with innumerable island galaxies. But they also revealed how much of that universe is destined to pass out of our view, carried by the same cosmic expansion that brought it into being. It's a poignant realization that the light from countless billions of galaxies emitted eons ago is fated to recede forever beyond the boundary of our observable universe, never to meet the eyes of any terrestrial astronomer. The secrets they hold, the cosmic stories they could tell, remain untold, a reminder of the tantalizing vastness forever beyond our reach. As we contemplate this, we might feel a sense of melancholy, perhaps even loneliness. To know that so much of the cosmos is slipping continuously out of our view can make the darkness of the night sky seem a little emptier. The observable universe, vast as it is but a diminishing island in the uncharted ocean of an ever-expanding cosmos. But I think there is beauty and poetry to be found here too. The expansion of the universe is, after all, a key part of the story of us. Without it, the raw material spat forth in the Big Bang may never have coalesced into galaxies, stars, planets, and thinking beings like ourselves. We are, each of us, children of the cosmos, our atoms forged in the hearts of long-dead stars and gathered together on this pale blue dot we call home. And though much of the universe may be forever hidden from us, we can still marvel at the ingenuity and dedication of thinkers like Edwin Hubble, who peered deeper into the universe than anyone before him and revealed just how immense and majestic our cosmos truly is. His work is a testament to the power of human curiosity, a ceaseless drive to explore, question, and understand. As we drift off to sleep, let us hold on to that sense of wonder, secure in the knowledge that we are part of an amazingly grand, complex, and mysterious universe. The cosmic horizon may limit how much of it we see, but it can never constrain our capacity to imagine, to dream, and to revel in the magic of the cosmos. In that sense, the universe within us is every bit as vast and limitless as the universe without. Perhaps, as we slip into our dreams, we can take a moment to whisper a quiet thank you to Edwin Hubble, and to all the scientists and thinkers who have dedicated their lives to uncovering the secrets of the cosmos. Their work has gifted us a universe far grander and more inspiring than our ancestors ever dared to imagine. And while much of it may lie beyond our reach, the bit we can see, filled with billions of galaxies, trillions of stars, and endless potential for wonder, is more than enough to fuel our curiosity and awe for generations to come. So let us embrace the mystery and the majesty of the cosmos as we drift off to sleep, comforted by the knowledge that we are part of a grand, endlessly fascinating universe. Our dreams may take us to the farthest reaches of space and time, but always with the secure anchor of our cosmic home, this delicate, life-bearing world adrift in the immensity of space. Good night, and may your dreams be as vast and wondrous as the universe itself. The universe, as revealed by Edwin Hubble, George Lemaitre, and generations of astronomers and cosmologists since, is a place of unimaginable scale, complexity, and mystery. Its story spans billions of years and billions of light-years, from the quantum fluctuations of the infant cosmos to the majestic dance of galaxies across the eons. And yet, for all its vastness, the universe is also deeply connected to us. The calcium in our bones, the iron in our blood, the oxygen we breathe, all were forged in the furnaces of ancient stars. We are, in the most profound sense, children of the cosmos, our story interwoven with the story of the universe itself. Perhaps that is why the question of what lies beyond the cosmic horizon holds such enduring fascination. It's not just a matter of astronomical curiosity, but a deeper yearning to understand our place in the grand tapestry of existence. When we gaze up at the night sky, we are looking not just outward, but inward, confronting the mysteries of our own origins and destiny. The idea that much of the universe is forever hidden from us can evoke a sense of cosmic loneliness, a melancholy at the thought of all the wonders we will never see. But it can also inspire a deep sense of connection and gratitude for the patch of the cosmos we call home. Our observable universe, vast as it is a rare and precious oasis of light amid the vast, dark expanses of the unknown. And within this oasis, on a small rocky world orbiting an ordinary star, the universe has given rise to beings capable of studying and marvelling at its grandeur. Through the work of Hubble and so many others, we have come to see the cosmos in a new light, not as a static backdrop, but as a dynamic, evolving entity of which we are an integral part. So as we contemplate the edge of the observable universe, let's remember that the greatest frontier lies not out there, but within us, in our capacity for wonder, discovery, and understanding. Every time we pursue a question, every time we peer through a telescope or ponder an equation, we are participating in the universe's journey of self-discovery. And though our individual lives may be fleeting compared to the eons of cosmic history, we each have a role to play in this grand story. By seeking to understand the universe, we add our voices to the chorus of generations who have gazed at the stars and dared to dream of what lies beyond. As we prepare to sleep, let's carry that sense of wonder and connection with us. Let's dream not just of distant galaxies and cosmic horizons, but of the boundless potential within each of us to explore, to discover, and to make our own small but meaningful contribution to the great cosmic story. And let's hold fast to the knowledge that, though the universe may be vast and much of it hidden from our view, we are nevertheless an integral part of its intricate web. In the words of Carl Sagan, "We are a way for the cosmos to know itself." That is a profound and humbling truth, and one that can guide and inspire us as we navigate our own brief but momentous journeys through space and time. So good night, and may your dreams be filled with the wonder and mystery of the cosmos. Remember, the universe is not just out there, it's also within you, a part of you, just as you are a part of it. Embrace that connection, and let it be a source of comfort, inspiration, and endless fascination, tonight and always. The story of the cosmos is still being written, and each of us has a verse to contribute. Make yours one of curiosity, compassion, and ceaseless wonder at the majesty of it all. As we ponder the far future, our minds may drift to the great thinkers who have shaped our understanding of the cosmos and its ultimate fate. One such visionary was the physicist Freeman Dyson, who in the 1970s imagined how intelligent life might harness the energy of an entire star to power a thriving civilization. Dyson proposed that advanced beings could construct a vast, spherical shell around a star, capturing its light to provide a nearly limitless energy supply. These hypothetical megastructures became known as Dyson spheres. A Dyson sphere would be the ultimate feat of astroengineering, a shell of solar collectors encircling a star at a distance of perhaps 1 astronomical unit, about the distance of Earth's orbit. Building a complete Dyson sphere would require disassembling entire planets to harvest their raw materials. The interior of the sphere would provide a staggering amount of living space, equivalent to trillions of Earths. Dyson even imagined that a sufficiently advanced civilization might use the sphere's interior as a substrate for immensely powerful computation, a cosmic supercomputer with the processing power of an entire star. Of course, Dyson spheres remain firmly in the realm of speculation. No evidence of such structures has ever been found. But the idea highlights the incredible potential of harnessing the power of the stars themselves. In our universe's distant future, when the expansion of space has carried the galaxies beyond each other's horizons, a Dyson sphere might allow a civilization to thrive for eons in the darkness. As the eons tick by and the universe continues to expand and cool, even a star-encircling civilization may find its days numbered. On nearly unimaginable timescales of 10 to the power of 100 years, an era so vast it's been dubbed the deep time by some thinkers. Even the largest black holes will evaporate into radiation via the process Stephen Hawking described in the 1970s. Hawking realized that the intense gravity at the edge of a black hole, the region known as the event horizon, can cause pairs of virtual particles to pop into existence. Normally, these pairs quickly annihilate each other, but if a pair appears right at the horizon, one particle may fall in while the other escapes as radiation. To a distant observer, it would appear that the black hole was slowly evaporating. Given enough time, even the most massive black holes will dwindle away, gradually radiating their mass back into the ever-expanding void. What an almost unfathomable scene to imagine. A cosmos utterly dark and diffuse, with the last vestiges of its once grand structures and cataclysmic engines, finally giving way to an eerily peaceful sea of radiation. Some thinkers, like the physicist Roger Penrose, have even speculated that this cold, diffuse, infinitely expanding state could set the stage for a new cosmic cycle. The vast distances between the decaying particles would render the very concepts of space and time nearly meaningless. Quantum effects might therefore predominate again, as they likely did in the universe's earliest moments. Could this fade into entropy, then somehow spark the birth of a new universe? The notion is highly speculative, but it's a captivating idea. One universe's bleak end, sowing the seeds of another's vibrant rebirth. As we contemplate these mind-bending vistas, from Dyson spheres harnessing the power of the stars to a possible endless cycle of cosmic deaths and rebirths, it's hard not to feel a profound sense of awe, tinged perhaps with a bittersweet melancholy. The universe is grander and more mysterious than we can fathom, and yet we've been gifted the ability to ponder its workings, to trace its history and imagine its future, to tell its story. The great thinkers and explorers we've encountered in our journey, from Edwin Hubble probing the distant galaxies to Andre Linde imagining an eternal multiverse, all shared this priceless gift, the ability to ask profound questions about the cosmos and our place within it. Each one of them, through their brilliant insights and courageous ideas, shone a light into the vast unknown. So as we drift towards sleep, let's hold on to that light. Let's celebrate the incredible human capacity for wonder and discovery that's carried us to the very edge of the universe, and though much may lie beyond our view, cloaked tantalizingly behind a cosmic horizon, let's treasure the slice of space and time we call home, this breathtaking corner of the cosmos that, for a brief flicker, we have the privilege to explore. Our search for understanding may never be complete. There may always be another horizon to chase, another mystery waiting just out of view. But therein lies the beauty. The pursuit of knowledge is an eternal voyage, a continuing legacy passed down from the visionaries of the past to the explorers of the future. It's a flame carried by all those who dare to dream beyond the edge of the known. So as you settle into the embrace of sleep, let your mind wander freely through the grand cosmic expanse. Follow in the footsteps of Hubble and Hawking, Lemaitre and Linde, and all the other great thinkers who've guided us on this journey, and know that you too are part of this great story, a participant in the universe's profound unfolding. The darkness beyond the edge of the universe may always beckon, an eternal mystery, but the light of human understanding shines brightly, illuminating our way to the farthest reaches of space and time. So keep that flame of curiosity burning, even in the quietest, most restful moments, for it's in our dreams and ponderings that the universe truly comes alive. As the last glimmers of wakefulness give way to the restful hush of sleep, know that you are forever connected to the cosmos, an integral part of its grand tapestry. You are stardust pondering the stars, a universe learning about itself, and that is a profound and beautiful thing. So rest well, my fellow explorer. May your dreams be filled with the wonders of the cosmos, and may your curiosity forever light the way through the vast and awe-inspiring universe we call home. Good night, and sweet dreams. Here is part 5, continuing the story from the previous sections. As we drift along the cosmic currents, marvelling at the majesty and mystery of all that came before, our curiosity calls us to peer even further ahead, into the farthest reaches of the future. What ultimate fate awaits our universe in the eons to come? The cosmos is not static. It is an ever-unfolding story, dynamic and evolving on the grandest of scales. And one of the key players in this saga is dark energy, that enigmatic force that is causing the very fabric of space to stretch and expand at an ever-increasing rate. In the coming eons, as the universe continues to grow under the relentless influence of dark energy, cosmic structures will be reshuffled and reshaped. Galaxy clusters, those majestic metropolises of the cosmos, each home to hundreds or thousands of galaxies, will merge and coalesce under the inexorable pull of gravity. Cosmic collisions and cannibalism will give rise to ever more magnificent galactic assemblages. Yet at the same time, dark energy will be pushing space itself apart from within, counteracting gravity's pull. In about 100 billion years, galaxy clusters beyond our local group will have been carried beyond our cosmic horizon by the expansion of space, never to be seen by us again. These distant denizens of the universe will become isolated island universes, marooned in an ever-widening sea of space-time. Even within these galactic archipelagos, the passage of deep time will bring profound transformations. The hearts of galaxies, Those brilliant beacons of light where new stars are born in resplendent stellar nurseries will gradually grow dim and still. Star formation will sputter out as gas and dust are depleted or too diffuse to condense into shining new suns. The last generation of stars will burn through their fuel, blazing defiantly against the encroaching darkness before exhausting themselves and fading out. One by one, these nuclear furnaces will wink out, leaving behind only cooling embers, black holes, neutron stars, and cold white dwarfs. In time, perhaps after hundreds of billions of years, galaxies themselves will fade from view, their stellar fires extinguished, reduced to shadowy collections of darkened remnants. Only the feeble glow of ever-cooling stellar cinders will remain, a ghost light echoing the luminous glory of eons past. But even these remnants are not eternal. Over timescales that defy imagination, exceeding trillions of years, the inexorable drumbeat of thermodynamics will see black holes slowly evaporate and vanish, yielding their mass back to the void via the whisper-thin trickle of Hawking radiation. Matter itself will decay into a tenuous gruel of fundamental particles, a thin mist permeating the ever-expanding void. And so we come to contemplate the heat death of the universe, its final state of maximum entropy, where the cosmos has reached thermodynamic equilibrium. The temperature and density will asymptotically approach absolute zero as space expands and cools forever. In this darkened realm at the end of time, where all coherent structure has been erased and dissolved, we can imagine only a still and silent void, an endless expanse of near-nothingness, where the possibility of change or complexity has been quenched by the march of entropy to its inexorable conclusion. It is a profound and poignant thing to envision the cosmos winding down to a cold, quiescent state on the nearly infinite horizon of deep time. There is a melancholy beauty in pondering this ultimate fate, this inevitable denouement in the cosmic drama. We are stirred to deeper appreciation for the light and life of the present era, knowing they are precious and fleeting gifts in an incomprehensibly vast universe. Even as we contemplate this far future of gathering darkness and silence, we must remember these are realms and possibilities that exist only in our minds, in the speculative reaches of cosmological theory and the extrapolations of physical laws. We are peering through a glass darkly, straining to glimpse the ultimate fate of all that is. And so, as we let this vision of a winding down universe carry us towards the shores of sleep, let us hold fast to a vital truth. There is still so much light to witness, so much discovery awaiting us in the here and now. We are living in a truly wondrous era, when the universe has opened itself to our questing minds, inviting us to unravel its manifold mysteries. Though the far future may trend toward a kind of beautiful bleakness, we need not hasten our thoughts to that distant prospect. There are still countless cosmic wonders to behold in the heavens above us, star clusters and nebula, pulsars and supernovae, galaxies and quasars in their untold billions and trillions. The same laws that will eventually lead to the heat death also gave rise to us, this improbable flowering of consciousness and curiosity, capable of deciphering nature's code and delighting in its many splendours. We are the universe awakening to its own majesty, however briefly, and that is a profoundly beautiful thing. So as sleep's warm embrace beckons, let us fill our minds not with visions of a darkened end, but rather with vibrant images of the cosmos in its glory, a symphony of form and light, from the delicate tracery of interstellar dust to the grand swirl of galaxies dancing across the firmament. We are part of this grand story, connected to the greater universe in ways both humbling and uplifting. Every atom in our bodies was forged in the crucibles of long-dead stars. We are quite literally stardust come alive, a way for the cosmos to know itself. Even as we drift off to our own ephemeral dreams, the universe continues to dream the great dream, the cosmic dance of gravity and light, energy and matter, space and time in their trillion-fold permutations. And though the music may someday fade, though the dancers may eventually disperse into the endless night, we're here now, awake, aware, and exquisitely tuned to the rhythm and rhyme of this grand cosmic ballet. In our fleeting moment under the stars, let us marvel and wonder and drink deeply of the light. Sleep well, dear dreamer, cradled in the arms of a universe so vast and so very, very beautiful. For this eternal instant all is illuminated. As we ponder the possibility of innumerable bubble universes sprouting from the quantum foam of an eternally inflating multiverse, it's natural to feel a sense of awe and perhaps even a tinge of insignificance. If our entire cosmos is but one humble bubble among countless others, each potentially harbouring its own unique physical laws and properties, what does that mean for our place in the grand scheme of things? It's a question that has captivated some of the greatest minds in modern cosmology. In the 1980s, physicists like Andrei Linde began to seriously explore the idea of eternal inflation and the multiverse. Linde, a Russian-American theoretical physicist, made pioneering contributions to the theory of cosmic inflation and became one of its most prominent advocates. Born in Moscow in 1948, Linde showed an early aptitude for physics and mathematics. He earned his PhD from the Lebedev Physical Institute in Moscow and later worked at CERN, the European Organization for Nuclear Research, before settling at Stanford University in the United States. It was there, in the early 1980s, that Linde began to develop his groundbreaking ideas about inflation and the multiverse. Linde's work built upon the earlier theories of Alan Guth and others, who had proposed that the universe underwent an incredible exponential expansion called inflation in its first fraction of a second. This rapid expansion could explain many of the observed features of our cosmos, like its smoothness and flatness on large scales. But Linde took the idea a step further. In Linde's eternal inflation model, inflation never completely ends. Instead, quantum fluctuations cause different regions of the inflating space to randomly stop inflating and form bubble universes, while inflation continues elsewhere. This process goes on forever, endlessly sprouting new and diverse bubble universes in a vast, ever-expanding multiverse. It's a mind-bending concept to wrap one's head around. In this view, our entire observable universe, with its billions of galaxies and trillions of stars, is just one humble bubble in an inconceivably vast sea of bubble universes. Each of these universes may have its own distinct set of physical constants and properties, determined by the random quantum fluctuations that gave birth to it. Some universes may be vastly different from ours, with wildly altered strengths of forces like gravity and electromagnetism. Others may be more subtly varied, perhaps with a slightly different ratio of matter to antimatter, or a different mass for the electron. In some universes, complex structures and even life may be possible, while others may be too chaotic or fleeting for anything interesting to form. It's a vision of reality that is both humbling and awe-inspiring. Our universe, grand and majestic as it appears to us, may be just one facet of an unimaginably greater whole. And if inflation is truly eternal, then the multiverse is not only spatially infinite, but temporally infinite as well. It had no beginning, and it will have no end. A never-ending story of creation and possibility. Of course, the idea of the multiverse is still speculative and controversial among physicists. While eternal inflation is a leading theory of cosmology, it's difficult to directly test or observe other bubble universes. Some argue that the multiverse is more of a philosophical concept than a scientific one, an unfalsifiable hypothesis that lies beyond the realm of empirical science. But for Linde and other proponents, the multiverse is a natural consequence of our best theories of the early universe. It arises almost inevitably from the marriage of cosmic inflation and quantum mechanics. And even if we can't directly observe other bubble universes, the theory makes certain predictions about the properties of our own cosmos that we can test, such as the distribution of galaxies on the largest scales. As you lie in bed, letting your mind drift through these heady cosmic thoughts, it's okay to feel a sense of smallness and even a tinge of existential vertigo. Contemplating the vastness of the multiverse and our place within it can be both exhilarating and unsettling, but it's also a testament to the incredible power of the human mind to ponder such profound questions and to reach so far beyond our earthly origins with the tools of science and mathematics. In a way, the multiverse is the ultimate expression of nature's creativity and diversity. Just as the biological evolution of life on Earth has produced an astonishing variety of forms and adaptations, the evolution of universes in the multiverse may have generated a kaleidoscopic array of physical realities, each unique and precious in its own way. And while we may never be able to visit or even observe these other universes, we can still appreciate the fact that we are part of something much grander than ourselves. Our universe may be just one island in an archipelago of universes, but it is our island, and it is endlessly fascinating in its own right. As you start to feel sleep gently beckoning, take a moment to marvel at the sheer audacity of the human intellect, to have risen from the African savannah to contemplate the multiverse in just a few million years. We are the universe becoming aware of itself, gazing out into the cosmic ocean with eyes wide with wonder. And while our individual lives may be brief and our corner of the cosmos may be small, we are still an integral part of the grand cosmic story. The atoms in our bodies were forged in the hearts of ancient stars, and the light in our eyes is a reflection of the first light that ever shone. We are stardust pondering the stars, a fitting testament to the universe's capacity for beauty, complexity, and self-discovery. As you finally drift off to sleep, let your mind wander through the multiverse one last time. Picture the endless cascade of bubble universes, each a unique expression of nature's infinite potential. And know that somewhere out there, perhaps in a universe with physical laws not too different from our own, other conscious beings may be pondering the same profound questions and marvelling at the same cosmic grandeur. It's a strangely comforting thought, that even in an infinite multiverse we are not alone in our pursuit of understanding and our capacity for wonder. So dream well, dear listener, and may your voyages through the cosmic ocean of your imagination be filled with beauty, insight, and the joy of discovery. And when you awake, remember that the same universe that dreamed up the multiverse also dreamed up you, a conscious, curious being capable of pondering its own existence. That in itself is a truly marvellous thing. And if you enjoyed this journey to the edges of the cosmos and the frontiers of human thought, please consider liking this video and subscribing to the channel. Your support helps to keep the spirit of curiosity and discovery alive, and ensures that we can continue to explore the biggest and most profound questions in science together. Because in a universe as vast and mysterious as ours, there's always more to learn and more to marvel at. The story of the cosmos is still being written, and we all have a part to play in unravelling its secrets. So stay curious, keep exploring, and never stop dreaming of what lies beyond the horizon. The universe is waiting for us, and the best is yet to come. Thanks for listening, and until next time, good night and sweet dreams.